Let us solve some examples of Newton's forward interpolation formula. So let us have Newton's forward interpolation formula. The formula is like this. You are given value of x and fx. So you are given x0, x1, x2 and so on, xn. This is y0, y1, y2 and so on, yn. Now here the excise value are having the equal length, or you can say equal subinterval, like 1, 1.2, 1.4, 1.6. Sometimes this value you are given y0, y1, y2, yn. Sometimes function is given and we have to find out the value yi by using calculator from the function. So here length is equal and we call it is as say h. Okay, the formula is like this. We need to prepare the table. We prepare the table like this: x values, y value, then here x0, x1, x2, say x3, like y0, y1, y2, y3. Then we call like this is delta fx or delta y, and you need to find out here the difference here like this: y1 minus y0. So here same way, find the difference, write down the difference here like this: y2 minus y1, y3 minus y2. Then second difference is again take the difference of these two, take the difference of these two. So here you have some number, here also you have some number. So third difference, so here you take the difference of these two and here also you have some number. In the formula we have to use for the forward Newton's forward interpolation formula, you have to use these values in the formula, and the formula is like this. So first we find out r, and that is x minus x0 by h. X is here we are given x0, x1, x2, xn. We need to find out some value of the function between any value, say like 1.1, 1.2, 1.4, 1.6. Find the value of the function at say 1.3. Then this will become our x. So x minus x0 by h, that is nothing but r, and the value of the function at x is, this is the formula, and that is nothing but y0 plus r. First difference, this one, this is delta y0, this value is delta y0, this value is del square y0, this value is del cube y0. So r delta y0 plus r minus 1 by factorial 2 del square y0 plus r minus 1, r minus 2 by factorial 3 del cube y0 and so on. 3 factorial meaning 6. So that is the way you can find out the value. So let us solve one example. Use Newton's forward difference method to find the approximate value of f of 1.3 from the following data. So you are given data like this: x, fx, that is the value of y, and that you are given as 1, then 2, then 3, then 4. This is 1.1, 4.2, 9.3, and 16.4. So now we need to find the value at 1.3. So our x is 1.3. Okay? x0, this is x0. x0 is 1. Now h is the difference. So 1, 2, then 2 to 3, then 3 to 4. So h is 1. And r is x minus x0 by h. So that is equal to 1.3 minus 1 by 1. And so it is nothing but 0.3. That is r. Now we prepare the table. So this is x and y. So 1, 2, 3, 4. This is 1.1, 4.2, 9.3, 16.4. Now the first uh, forward difference, that is 4.2 minus 1.1. So in between you write that is 3.1. Then 9.3 minus 4.2. So you have 5.1. Then 16.4 minus 9.3. So you have 7.1. Then next, second difference. So that is 5.1 minus 3.1. That is 2. Then 7.1 minus 5.1. That is also 2. And the third is this 2 minus 2. And so it is 0. So we need to use in the formula these values. Okay. So let us write the formula. So by Newton's forward interpolation formula, that is f of x equal to, it is y0 plus delta y0, sorry, plus r times delta y0 plus r minus 1 by factorial 2 del square y0 plus r minus 1, r minus 2 by factorial 3 del cube y0 and so on. So now we want to find the value at 1.3. So f of 1.3, y0 is 1.1, this is y0. R, we already found R, that is 0.3. So plus zero point 0.3 into delta y0, it is 3.1 plus r zero point 0.3, r minus 1.3 minus 1 by 2, and del square y0 is 2 plus, now r minus 1, r minus 2 by 3 factorial del cube y0, but del cube y0 is 0, so we write this as 0. And we use the calculator and find out the value here, and it is 1.82. So that is the value of the function at 1.3 by using Newton's forward interpolation formula. We take one more example. Find value of sine 52 degree by using Newton's forward interpolation formula. Take theta 45 degree, 50 degree, 55 degree, 60 degree, and do take 4 digits after the decimal points. So here we need to find the value of the function also. So let us first find the value of the, okay, first find the, uh, okay, let us first find the r. So here you are having x is 52 degree, x0 45 degree, and h 45 degree, 50 degree, 55 degree, 60 degree, so 5 degree, and r equal to x minus x0 by h, and so that is 52 degree minus 45 degree divided by 5 degree. Use the calculator, you will get 1.4. Now we need to find the value of sine function also, so we need to use the calculator, but here you need to take care degree mode. Your calculator should be in degree mode. So here x value is our theta and y value is sine theta. It is 45 degree, 50 degree, 55 degree, and 60 degree. Now use the calculator, degree mode, find the sine 45 degree, and if required round off the number also. So when you use the calculator, you can verify here also when you solve this example. Sine 45 degree 0.7071, same way 50 degree 0.7660, 55 degree 0.8192, and this is 0.8660. And now we prepare the table. The first difference, so take the difference 0.7660 minus 0.7071. So write down here, this is 0.0589. Same way here, take the difference 0.0532. Here also 0.8660 minus 0.8192. So that is 0.0468. Same way you take the second difference. So this minus this. So 0.0532 minus 0.0589. It is negative of 0.0057. Same way here take the difference. It is negative of 0.0064. And same way you take the third difference, minus 0.0064 and minus plus. So minus 0.0064 plus 0.0057. So that is negative of 0.0007. So this is the table, and we need to consider this value when we use the formula. So the Newton's forward interpolation formula. So here fx is sin x. So we need to find the value at 52 degree. So we directly write like this. Okay, so this is fx equal to formula is y0 plus r delta y0 plus r minus 1 by 2 del square y0 r minus 1 r minus 2 by 6 3 factorial del cube y0 and so on. So now this is sine 52 degree. So sine 52 degree y0, so 0.7071 plus r is 1.4. So this is 1.4 into delta y0. So that is 0.0589 plus 1.4, 1.4 minus 1 by 2 del square y0. It is minus 0.0057, then plus 1.4, 1.4 minus 1, 1.4 minus 2 by 6, and the last, this one, minus 0.0007. Now here you need to use the calculator properly. Use the calculator and verify that you are having answer as 0.7880. So approximately value of sine 52 degree is 0.7880. Thank you.